Okay, so I guess we are live. So this is going to be the very first lesson of our DevOps journey. We will be starting with Linux. So today we will be going through some of the history of Linux that majorly no one talks about. When I say that nobody talks about, it's the story of UNIX, MINIX, Linux, and some other stuff. Well, we all know what a Linux is. But if I ask you, is Linux a kernel or is it an operating system as its own? So we will be clearing those little fundamental topics that uh, as a software engineer you should know. So the very story begins at 1969. So at that time around, we got our first operating system called Unix. Now, Unix was made at AT&T Labs. So let's try to write that up somewhere. We can create a little bit of notes. So, Unix. Hmm. Created at AT&T Labs. When was it created? In 1969. Okay. Now, the people who created was Ken Thompson and Dennis Ritchie. Okay. Well, at the very beginning, this was really cool, was something new for us, but there was a little problem that this particular operating system was proprietary. So when we talk about a proprietary systems, it means that only a particular organization can use that software, which means that if as a normal human being you wanted to access that operating system, you actually could not. So that is why many of the educational institutions such as Harvard, Stanford, and other universities who wanted to explore more about technology, more about operating systems, could not use this operating system, that is Unix. So that is when a guy named Andrew S. Tannenbaum created another operating system which was actually a miniature version of Unix itself and called it MINIX. So MINIX actually stands for miniature Unix. All right, created by Andrew S. Tannenbaum. When was it created? In 1970s. Only for educational purposes. Again, this was another problem that was created here because even now, this Minix operating system, now as it was available for other universities and educational institutions to use for educational purposes, as a normal human being, you could not still use an operating system. You cannot have a laptop in 1970s. See, that that creates a little bit of inconvenience for all the students who wants to be in such a field. That is when our boy Linus Torvalds created the biggest, the most famous, the operating system that runs 80% of the entire internet, called Linux. So this operating system, now it has got a lot of story behind it. Even the name Linux wasn't actually given by Linus Torvalds. So we will dive into it at some later point in time, but let's see the basics now. created by Linus Torvalds in 1991. Version 0.01 consisted of only 10,000 lines of code. So the problem that Linus Torvalds had was that he wanted to create an operating system, not entirely an operating system, but some kernel that was accessed that could be accessed by anyone. So the difference between a MINIX, a UNIX, and a Linux operating system was basically based on proprietary. Unix and MINIX, being a proprietary software, couldn't be used by anyone. Linux, being an open source platform, anybody could directly download the source code and update that particular kernel according to his needs, which means I, as of now, can create can download that particular source code from GitHub and make my own changes and use it or publish it as a new software. See, Linux was initially a kernel, right? See, the thing is, for an operating system, you need something just more than a kernel. A kernel is the heart of an operating system. So, an operating system has a lot of things out of the box that is kernel, right? So, for example, kernel is the heart of operating system, but operating system also has bootloaders, booting softwares, right? Memory management, CPU schedulings. Well, most of these things are still done by a kernel, but still it has got a lot of other things other than the operations that are done by kernel. So for that, in 1980s, a person, his name is Richard Stallman. He wanted to create a foundation which would focus more on open source softwares, which means people could create open source softwares, could make their side projects public so that they can be accessed by other people, by anyone around the globe. So that was the entire motive, the goal of Free Software Foundation. It was created in 1980s, and Free Software Foundation is the one that gave birth to GNU project. So, as I said earlier, a kernel needs something else than its own to be called as an operating system. So what are those? What are those things that I'm talking about? See, a kernel plus a third party libraries plus compilers to run programs, right? And mm, transpilers maybe, and let's call it a day. So etc. So all of these things together will be called an operating system. So we have already got a kernel, that is Linux. Now we need all of these other stuff, other cool, very complex stuff to be called as an operating system, to create an operating system. So that all cool stuff, that complex coding stuff was provided by GNU. So you will find the full form of GNU very humorous because full form of GNU stands for GNU is not Linux. It is a recursive, pretty humorous, I think, Full form of GNU is GNU is not Linux. GNU is not Unix, not Linux, not Unix. GNU is not Unix. It it is kind of saying that GNU is not proprietary like Unix softwares. So that was their entire motive. And kernel, not kernel, but Linux plus GNU creates something called Linux operating system. Here, this is the Linux kernel and this is Linux operating system. So I think this is one of the biggest confusions out there, that if the Linux is a kernel or Linux as an operating system. So this would clear that up. Both the operating system and kernel is named after Linux. Anyways, so there is an interesting story behind the name itself. See, the first copy of the code, the source code that Linus Torvalds pushed into the UDP server, he called his project, the initial name that was given by Linus Torvalds himself was Freaks with an X. I mean, it's not really pretty cool, right? Like Linux. I mean, Freaks is, I don't know, I can't think of myself using an operating system called Freaks. Okay, so, anyways, the name given by Linus Torvalds to this software, to this kernel, is Freaks. But there was a UDP administrator at that time in 1991. Her name was Ari Lemke. So Ari saw these files, and she saw the name Freaks, and she did not like that name. So without consenting with Linus Torvalds himself, the man who made the project, she did not even consent him, and she named the project Linux. So that's how the entire globe knows this operating system as Linux, not Freaks. So that is an interesting story behind it, but not and not much people know about it. Well, this means that I have done a significant amount of research. Anyways, a little bit other technical stuff about Linux is that it follows a micro, not micro, a monolith architecture. If you don't know what monolith and micro services are, well, it doesn't really matter, because hey, monolith means the entire major stuff that is controlled by the operating system. For example, the memory management, the CPU scheduling, the device drivers, virtualizations, all of those major important tasks are compiled at only one place. They exist inside one single storage, that is kernel. There is another architecture called micro kernel architecture, in which there are some separation of concerns. What I mean by that is that only the important parts, such as CPU scheduling and memory management, they are kept at kernel, and all the other parts, they are kept at the user space. If you don't know about all of this stuff, you can simply watch a video on YouTube. There are a lot of videos out there. But on a very high level, what I'm trying to say is monolith kernel versus micro kernel. Let's see if there is an interesting image. Here we go. Apologize, I'm pretty sick. See, what monolithic kernel is, that VFS stands for, I guess, virtual file server, but all of these important stuff, VFS system calls, inter-process communication, the file systems, the virtual memories, device drivers, and more, all of these are actually at the hardware level. It is in All of these are actually handled by the kernel itself. Whereas inside a more, if you look at microkernel, only the basic IPC, virtual memory, and scheduling are kept at kernel space, and all other, see, application IPCs, the servers, the device drivers, all of these are kept at the user space, which is close to application. So the advantage of using a microkernel is that if there is even a single bug inside any of these sections, the entire um, the entire kernel or the other services will not go down. If we compare that to this, as because every other major stuff is kept at a single at a single space, at the kernel space itself, if there is even one single bug in any one of them, the entire structure will go down. So that is one of the disadvantage of monolithic kernel. But if you ask me, then why does Linux uses a monolithic kernel? It is because how fast it is. There is something called switching between user space and kernel space. It had a name, context switching. Yes, exactly. Just remembered. It is called context switching. So it is basically the switching of um, the, what can we say, the power of execution between user space and kernel space, which means if I want to access hardware, I'll have to switch between user and kernel. I'll have to use the hardware, the laptop have to switch from the user space to the kernel space to access hardware. This is called context switching. In case of monolithic kernel, the context switching is minimum. So the applications, it runs really fast. Even I have an old MacBook with me. It's around the edition of 2015, and I have installed Linux in it. It runs really smooth compared to Mac OS. So that is one of the advantages of using monolithic. I think that was it for today, because we have covered majorly the history of Linux operating systems, how it was born. Um, yeah, if you want, I've created a documentation, a very deep documentation. It is a basically a Gemini report and ChatGPT and other resources that are found. I can share this with you, and you can see even you can study even deeper into all of these stuff. So yep, that is it for today, and I think I'll see you tomorrow. Okay, where is my